Obviously, most objects reflected in a mirror are not an infinite distance away, so their images are not going to be perfectly focused on the focal point. In order to determine the image location for an object not at infinity, we need to draw what is known as a ray diagram. A ray diagram consists of 3 rays of light reflecting off of the mirror to some point, called the object point. So say we have some object that is located fairly close to a concave mirror. If we measure the distance from the center of the mirror to where the object is located, we call this the object distance and give it the designation of d sub O. The first ray of light leaves the object and is drawn parallel to the principal axis. As we saw before, the light rays that hit the mirror in a parallel fashion will reflect back through the focus. The second light ray leaves the object and is drawn so that it travels through the focus to the mirror. Any ray that travels through the focus will reflect parallel to the principal axis, and at some point this ray will intersect the first ray. The third ray is drawn in a way so that it travels through the center of curvature, hits the perpendicular to the mirror, and travels back on itself. If drawn correctly, this ray will cross the first 2 rays at the same point. So the 3 rays leave a single point on the object, reflect off the mirror to a single point called the image point. Actually, any light rays originating from the object point and reflecting off the mirror will meet at the image point. But we really need only 3 types of rays to determine where the image point will be located. Now we have drawn a ray diagram for a single point on our object. We could actually draw a ray diagram for any number of points on our object in order to determine where those points would be imaged. All of these rays together will form an image of the original object. Since the light rays actually pass through this image, it is called a real image. If we were to put a white surface or film at that location, we would actually be able to see the image. The analysis we did for concave mirrors can also be used for convex mirrors. The first ray we draw parallel to the principal axis. This ray will reflect back at an outward angle. If you were looking into the mirror, it would appear that the ray was coming from behind the mirror. The second ray leaves the object and reflects off the mirror along the principal axis. The ray again reflects in a way that appears to come from behind the mirror. The third ray leaves the object and reflects in a manner parallel to the principal axis. The point where the rays appear to originate behind the mirror will be where the image forms. Since the light rays do not actually pass through the image, we again call this a virtual image.